Okay, now on to net ionic equations. This has several steps. And a net ionic equation is the net reaction where we only write the changes that occur. If there's no changes, there's no reaction. So let's start off with this guy here. To write the net ionic equation, the first thing that we need is the balanced chemical equation. Most problems will ask for both, at least I do in my class. So let's start off the same way that we always do. Translate from words into symbols. Four different ions makes this a double replacement reaction, so all of my ions will swap. So manganese now goes with the nitrate, and mercury now goes with the chloride. To balance this right quick, I'll go through the whole process just so you can see it. 1 over there, 4 over there, 1 and 1, and 4 and 1. So my nitrates are not balanced. So let's see, I got 4 over here and 4 over here. So if I put 4 there, that gives me 4 chlorides and 4 mercuries, and 4 there, 4 mercuries, 4 nitrates, yay. Alright, balanced chemical equation. This is always your step 1, is to identify products. I'll keep a running tally over here. Is translate. 2 is pick your type. And predict products. Make sure that all of your compounds sum to 0. After that, we're going to balance, which we just did. Now we're going to do solubility. So we're going to use those rules we talked about in the last video to identify which of these compounds are soluble and which is solid. In order for a chemical reaction to have occurred here, I need a change, something that is on the left that looks different on the right. So our first substance here, mercury nitrate. Let's go through our rules and find one that applies. Rule 1, all common compounds of group 1 and ammonia are soluble. Well, mercury is neither. Doesn't help much. Rule 2, all nitrates, acetates, and chlorates are soluble. Well, heck, I have a nitrate. That makes mercury nitrate soluble. Next one is manganese 4 chloride. So let's go back to the top. Common compounds of group 1 and ammonia, well, got neither. 2, acetates, nitrates, and chlorates, didn't have any of those. Binary compounds of a halogen with a metal. Hey, look, metal, halogen, woot! And manganese is neither silver, mercury, nor lead. So this guy is also soluble. Next up, manganese 4 nitrate. Rule 1, common compounds of 1 and ammonium, nope, doesn't help. 2, nitrates are soluble. Yay. And last but not least, mercury chloride. Group 1, ammonia, nope, none of those. Nitrates, acetates, chlorates, nope, doesn't apply. Binary compounds of halogen with a metal. Metal, halogen. But mercury was one of my exceptions. So this guy here is in fact a solid. I have made a solid where I did not have one before. So something has changed. I do in fact have a chemical reaction. So the next thing we're going to do is to dissociate all of our ions, all of our compounds that have that AQ behind it. Make sure to carry your coefficients all the way through. So for mercury, since we're breaking them into ions, make sure you include the charges here. So there's my mercury nitrate. Now for my manganese chloride, 1 manganese. Remember, all of our ions dissociate, so I have 4 chlorides. That takes care of the left side. On to the right. Manganese 4 and our 4 nitrates from here. And last but not least is my solid. You cannot break apart the solid. It must be written just as is. Our next step is to cross out anything that does not change. So if it is on the left and the right and it looks identical, I don't care. So, mercury ion, mercury in a solid. That changed. Gotta keep it. 4 nitrate, 4 nitrate. Looks the same. Don't care. Manganese plus 4, manganese plus 4. Looks the same. Don't care. 4 chloride, chloride in a solid. Looks different. Now, all of these guys here that we crossed out, these are called spectator ions because they don't do anything. They just watch. This big old long thing where we wrote all of our ions is called the complete ionic equation because it has all of the ions. Since it is the complete ionic, make sure that everybody's got a charge. The last step is to write down everything that did not change, or everything that did change, excuse me. So that was my mercury, my chlorides, and my solid. Make sure you include that solid. I got a 4 all over the place. I don't need that. I can reduce it down. So here is my net ionic equation. My net result, the ions and who changed. So it's a little bit of a process, but it's a fairly linear one, I hope. So let's try another one before I run out of time on my video. So down here, step number 1 is still to translate into symbols. Fe, 3 plus, Br, 1 minus, reacts with potassium carbonate. 4 ions makes this a double replacement. Make sure to balance all of your charges before you start balancing number of atoms. So there we go. Now let's balance our equation. Let's see if I can do this one in faster time. I put a 3 there, and a 2 there, and a 6 there. That should do it. Cool. See how fast you'll get at these if you keep practicing? Just keep at it. There is hope, I promise. Light at the end of the tunnel. Anyway, enough theatrics. Now for solubilities. So, FeBr3. So let's see. Which rule does that fit? Number 1, group 1, ammonium. Nope. Group number 2, nitrates, acetates, chlorides. Nope. Number 3, binary compounds of halogen and a metal. Hey, iron is a metal and bromine is a halogen. And iron is not one of those exceptions. He is aqueous. Next, potassium carbonate. All common compounds of group 1 with ammonia are soluble. Yay. Even though Rule 5 says that all carbonates are insoluble, it says except for Rule 1. So this rule still holds the final say. On the other side, iron carbonate. Now Rule 5 is important. That carbonate, not soluble. This guy here actually is doubly soluble. He just flat jumps into water. Group 1 and binary compound of a metal and a halogen. Why did I write AQ? That one gets an S, you yo-yo. S is solid. Sorry for my dumb moment. Okay. Now let us write the complete ionic equation by breaking everything with an AQ into its ions. Here we go. 2 iron with the charge. That 2 gets distributed over to the bromine as well, so that's 6 Br minus. See if I can help you relate them here. 6 potassiums because that 3 in the front, and 3 carbonates. That took care of one side. My solid I cannot change. That one's got to stay just as is. And then my potassium and my bromine on the back side. Complete ionic equation. Done. Finished. Excuse me. Finished. Done means I should turn it over and roast it on the other side. Anyway. Cross out what does not change. Iron ion, iron solid. Different. Forgot my S. Br ion, Br ion. Does not change. Spectator. 6K plus, 6K plus. Spectator. Ion, solid. Changes. So all that leaves is to write down our ions that do change. 2Fe 3 plus 3CO3 2 minus. Fe2 CO3 3 solid. Now a couple of things that are particularly important to note. 1. The law of conservation of matter does still hold. So 2 irons, 3 carbonates, 3 carbonates. So LCOM is still intact. Also, notice my charges on the ions. Since this is a net ionic equation, ionic, make sure you have charges. They are important. Your phase indicator, all these little things in parentheses are called phase indicators, and you need them. The ions, you assume your reader knows that ions are soluble. That's what that means, that they have dissociated in water. So this one, you're telling your reader, no, I'm not dumb. I meant to leave that together. So double check that before you turn this in. So there are a couple of examples for you. I hope that helps. If there's any further questions, post them down in the comments section down below. If you can see my finger down below the video, and I will get back to them as fast as I can. Best of luck and happy practicing.